No.
Hello, sir.
Hello, Pranav. Have you attended the week 8 lectures? Have you completed the week 8 lectures?
Sir, so today is the first date, sir. I am working now. That's a first date.
Okay. Oh, means you have not done the first to 8 weeks in the SWAM portal.
Sir, I have completed the assignment, sir, but this is the first time I attend the online live session, sir.
Okay. But you have attended the classes
Yes,
on
sir,
SWAM portal.
regularly. Yes, sir,
Okay.
yes, sir.
Okay. So eighth week you have done?
Sir, 8 assignment done, sir.
Okay. Okay. You're able to see the presentation?
Yes, sir.
Hmm.
It's not working, sir.
Okay. So we'll do some problems based on what studied on the week 8. There's one numerical also. So, two numericals. Extended problem. Pranay, let's wait for a few minutes if somebody joins. Otherwise, we will start at 7:10.
Okay, sir.
Today, it won't take much time. One numerical will take time.
Okay, sir.
Otherwise, all other questions won't take much time.
Sir, exam will be CBT or pen and paper mode, sir.
And like what, well, how we are taking the problem solving sessions, no? In this
Yes,
manner
sir.
only, like there will be some questions and there will be some options, there will be some numericals. So it will be online only, I think.
Okay, sir. Okay, sir. Okay, fine.
Okay, let's start. If no one is joining, let's start the.
Okay, sir.
Yeah. So we'll do in this manner only. We will like I will show the question. You try to attempt it, and after that we will discuss it. So this is the first problem. You try to attempt it, come up with an answer, then we will. What do you think? Which one is correct? The process of solidification involves changes in. So in week 8, sir basically discussed about the method solidification and stabilization. So
Okay.
different ways in which we can achieve solidification, stabilization, what are like for
In situ, ex
solidification.
situ.
Yeah, in situ and ex situ. In two ways it can be achieved, but and what materials we use. Like for solidification, we need binders such as cement
Yes,
and fly ash
yes,
and all
sir.
those things.
THS matrix formed.
Yeah, and stabilization, there is various ways like adsorption and biodegradation, you know.
Okay, sir.
So all these things. So based on that, the question is just asking that the process of solidification involves changes. So in solidification, what we achieve, like what is the purpose of solidification, and what we are achieving in stabilization. So whether these process of solidification is uh, brings physical like changes in physical properties or chemical properties in that way, you have to answer for solidification and as well as stabilization. It's a two-step
Yes,
process.
sir. Mm. Chemical properties of hazardous waste into physical properties.
The process of sorry,
Chemical
phys
properties of
phys
hazardous waste while
yeah,
stabilizing refers to
yeah,
changes in physical.
physical properties. Then here it will be physical.
Chemical as well.
Yeah. Second will be chemical. First, like solidification, as the name suggests, we are aiming to convert this whatever the contaminant present into solid state, sort of. So that's why we are using substances like cement and fly ash.
Mhm.
So
Yes.
when it reacts with
Blast
other,
furnace slag.
yeah, it
Yes.
causes CSH gel formation.
Yes, sir.
Fly ash we are using blast furnace slag, all those things, different construction materials we can use.
Yes, sir.
So so we are just looking for change in physical properties. But in case of stabilization, we are aiming that like if some
Chemical.
heavy metal is present,
Okay, sir.
so we don't want that heavy metal to leach out of the uh, whatever solidification we have done. So we need to stabilize it also. If even if we put that block in some anaerobic condition or some acid passes through or some water passes through, so we want to make sure
Mhm.
that it doesn't leaches out with the whatever solvent is passing in and around of the solidification blocks which we have created. We can't
Okay, sir.
completely avoid it, but we want to minimize it. So we
Yes, okay.
achieve through some chemical.
Minimize the
Um,
effect, sir.
yeah.
Next question.
Simple questions again. Which of the following can be used as binding reagent for solidification and
Fly
stability?
ash.
Fly ash,
Cement.
cement.
ஹரி போட்டுருப்பாங்க.
Can we
ஹரி
use lime?
போட்டுருப்பாங்க.
Can we use lime also? Can we use lime?
Sir, I am idea about cement and fly ash only, sir. I don't idea about lime, sir.
Okay. So, if we are using cement, cement basically we have both like calcium oxide.
Okay, sir. Okay, sir. Okay, sir. Like box compound.
Yeah, Box compounds. So
Okay, sir. Okay, okay.
yeah, Box compound, four Box compounds are there. Those things are okay. But in cement, basically we have,
Lime is the major part, sir.
yeah. So
Okay,
lime,
sir.
lime and as silicon oxide,
Okay,
and
sir.
then there's formation of CSH gel, which is
Okay.
basically calcium
Okay.
calcium oxide around 1.5 and SiO2 and 9 times of water. So this thing we call
CSK.
CSH. Yeah,
CSK matrix.
yeah. So this and there is also during this reaction there is formation of calcium hydroxide also.
Yes, sir.
So this CSH this C represent calcium, silicon, and hydrogen. So normally in case of cement we have like cement is basically made in such a way that it provides strength and it has all the things which are required to achieve to make CSH gel. But in case of fly ash is more rich in silicon dioxide, but it has some limited amount of calcium. So to achieve similar for CSH gel formation, sufficient amount of CSH gel formation, we need to provide calcium to fly ash, right? So you might have heard of OPC and PPC. Karunai, are you there? Karunai, are you there?
Sir, yes, sir. Yes, sir.
Yeah. So you might have heard of this OPC and PPC cement.
Yes, sir.
So in OPC is like ordinary Portland cement and PPC is pozzolana Portland cement.
Pozzolana Portland cement.
Yeah. So pozzolana basically is basically some fly ash is also added here.
Yes, sir.
So the fly ash is uh, we can say a sort of deficient in it has limited amount of calcium. So we need to provide calcium from outside. So
Okay, sir.
in case of cement, there is formation of calcium hydroxide, and if we mix it with PPC, well, like
Yes, sir.
cement plus fly ash, then this calcium will act as
Okay, sir.
the uh, like a reactant species
Okay,
for the SiO2 present in fly ash, so that will be okay. But if we are using just fly ash, then we need to provide some lime from outside. Like there, you if you have done the week it, you might sir have told about fly ash, which is type F and type C. So this type F fly ash, it has low amount of like low amount of calcium hydroxide. This is low, and in type C we have high amount of calcium hydroxide. So in case if we are using alone, if we are using fly ash, and assuming if it is type F, so it has less amount of calcium hydroxide. So for CSH gel formation, we need calcium hydroxide. So you can add from outside. So lime can be used in that way. So lime is also will be there.
okay, sir. Thank you, sir.
Okay. This is the third problem. Yeah. Which of the following outcomes are derived from the process of stabilization?
The decrease in solubility and increase in mobility, sir.
Decrease in solubility,
And increase in mobility.
increase in mobility. Okay. So
Yes.
stabilization like solidification we have discussed.
Okay,
Stabilization, we
sir.
are sort of trying that like whatever contaminant which we have put in this solidified form using some sort of binding material, that
Okay, sir.
that contaminant should not come out of that, like in the get it, like it might get dissolved if the material is permeable.
Okay.
When we design those systems, we try to keep the permeability of that particular binding material to be lower than compared to the surrounding, so that it takes
Okay,
the
sir.
least resistance path. But
Okay, sir.
what we are trying to achieve is that the contaminant should not come out of the solidified form which we have put.
Okay. Okay, sir.
So like what are the ways, like if this is the solidified form. So if water is flowing here, what we are trying to achieve through, if this water is coming, we don't want the contaminant to come out of the system through diffusion or dispersion and getting dissolved with this water and going to the surrounding, right? So
Okay.
so first is correct. We want
Yes.
that solubility should be low.
Okay, sir.
So in for example, in case of metals,
Okay, sir.
heavy metals,
Okay.
in case of heavy metals, low solubility we can achieve through increasing the pH,
Okay, sir.
right?
Okay, sir.
And here we have solubility. So as you increase the pH, there is decrease in solubility,
Okay,
and
sir.
after achieving a particular point, there will be again increase in solubility.
Increasing. Yes, sir.
Yeah. So like for lead Pb, there will be some pH at which this pH is around, like for example 9.2,
Okay, sir.
and after that there will be increase in salt. So do you know
Okay.
why there is increase in solubility again?
Sir, after reaching permissible limits, sir.
No, like after, like till, and there, like we started from pH assume 5,
Okay, sir.
and we are increasing the pH. So there
Okay, sir.
is the whatever lead was which was present as Pb2 plus, or in other form which was soluble in water.
Sir, it convert into alkaline form, sir.
Yeah, it converts into PbOH,
Okay, sir. Let
OH2X.
hydroxide this alkaline.
Yeah,
That's why it's increasing.
yeah, it will come out of the system.
Okay, sir.
This this the PbOH12 will come out of the system. No, it's not soluble.
Okay, okay, sir.
Uh, So, but by that logic, if we are increasing continuously increasing the pH,
Okay, sir.
this lead should totally come out of the system as we increase the pH value.
Okay, sir.
But after 9.2, or like a value around 9 or 9 and between 10, there is
Okay, sir.
reduction in there is increase in solubility again.
Okay, sir.
So, do you know why it happens that suddenly after reaching a particular point, a particular pH, there is a decrease in solubility?
No idea, sir.
Okay. So we will this on based on that this basis, there is one question in the presentation. At last, we
Okay,
have
sir.
one question. This is the question.
Okay, sir.
So you will,
Okay, sir.
you will, I will visit back this thing there again.
Okay, okay,
So for now, we first option is correct. We want decrease
okay,
in solubility of the contaminant. That's why we are doing
okay, sir.
stabilization, so that
Okay,
the whenever water comes, the lead should not get dissolved and come out of this solid white form and again in water. Then there
okay,
is
sir.
no meaning of doing solidification, right?
Okay.
So then the second option is increase in mobility of the contaminant. So
Okay.
what do you think meaning of this statement is?
The heavy metals are moved from one side to other side.
So do we want to increase this mobility
No,
of
sir.
the?
No, sir. Degrees.
So this
No,
this
sir. No,
won't
sir.
this won't be the answer, right?
Okay, sir.
So we want to decrease the mobility of contaminant,
Yes,
right?
sir. Yes, sir.
Then the fourth option is decrease in toxicity of the contaminant.
Yes, sir.
So do we want to achieve this also?
Sir, reducing the toxicity.
Yeah.
If increasing toxicity leads to environment
Yeah. So
environment impact, sir.
it will be desirable, na? Decrease
Yes,
to
sir.
decrease the toxicity.
Okay,
This
sir.
is also correct.
Okay.
So the decrease in solubility of the contaminant, decrease in mobility of
Decrease
the
in
contaminant,
mobility.
and decrease in
Decrease in
toxicity.
tox.
So these three options will be correct. So soil at site X is contaminated with liquid bromine. Which of
Good.
the following statements are correct? Incorrect.
Incorrect.
Incorrect. Incorrect. Yeah.
Option A. Sir, are you audible?
Yes, yes. What, what
Sir,
you are suggesting? What
option
is, huh?
option A.
Option A.
Hmm.
Solidification and stabilization technique cannot be used for remediation of site X because this is this is incorrect. Then,
Because in solidification stabilization we use solid waste, sir. Limitation of solid.
huh? No, solidification is we are converting the waste into solid form.
Okay, sir. Okay,
The waste is doesn't necessarily have to be solid.
okay, sir. Sir, two, sir. No idea, sir. This is
Okay, the first one is incorrect. Like solidification stabilization method can be used. We can
Hmm.
use like the water present in this liquid chromium. Like for example, we solidifying sludge,
Okay.
right? So, for example, we are using cement, right?
Yes, sir.
We are using cement and fly ash. And what
Yes,
for
sir.
this solidification, what do we need?
Convert the waste into solid form
Yeah,
by using binder.
cement is binder.
Yes, sir.
Cement is binder. But what do we need to add in cement to get it to solidify?
The acting is a binding agent.
Okay, you are civil engineer or you are from different branch?
Sir, civil engineer.
Civil engineer, no. So you might have
Yes,
worked
sir.
in concrete lab, right?
Yes, sir.
So in concrete lab, if when you were making the concrete cubes,
Yes,
so
sir.
what are the four different things you were adding?
Water, aggregate,
Water,
uh,
aggregate,
aggregate, cement,
cement,
some types of special concrete sheets are admixture, sir.
fine aggregate and coarse aggregate.
Yes, sir.
And if you are making some special concrete, then you will go for some other things.
Okay,
So,
yes, sir.
so so what is the component here? Like we are not adding aggregate and we are not adding fine and coarse aggregate here, right?
Yes, sir.
So in cement, what is the important thing which we need to add for the solidification?
Yes, sir.
Water, no, water.
Water, yes, sir.
Yeah, water we need to add. So,
Yes, sir.
for example, if we are solidifying a sludge, so
Yes,
the
sir.
sludge we have taken it from uh, some industry which it has some hazardous chemicals.
Yes,
So,
sir.
but in sludge, we have noticed that it is 90% water. So now can we use solidification method here? Jadab, Jadab,
Sir, yes, sir.
Jadab, are you here? Jadab,
Yes, sir.
uh, can you like would you able to tell whether we can like if we have a liquid waste, if we have a waste which has a water, so should we go for solidification stabilization method? Can we go for solidification stabilization method?
Sir, I am not able to tell you.
Okay. Uh, so this, if we are using solidification, we achieve by some binder, such as cement plus
Okay.
fly or fly ash,
Yes, sir.
right? So one important component which we need is water, right?
Yes, sir.
So in case of liquid waste, there is already water here.
Yes, sir. Yes, sir.
So additionally, which water we need to add can be reduced, right?
Yes, sir.
You must have remembered that when we do corrections for fine aggregate and coarse aggregate, we actually calculate how much water is already present in those aggregate, and we make corrections in water cement ratio.
Yes, sir.
है ना? So
Yes,
the
sir.
water which is present in pores of the coarse aggregate or surface of coarse aggregate, or in fine aggregates, right?
Yes,
Sands,
sir.
most of the times sand has some moisture, right? So
Yes, sir.
we make corrections in water cement ratio, or not in water cement ratio, how much water we are going to add.
Yes,
So
sir.
there is reduction in water which we add, right? So in the
Okay.
similar way,
Okay.
there will be reduction in what water we add in cement, because there is already water present in waste, right?
Yes, sir.
So we can use this method, right?
Okay, sir.
But we have to say which are incorrect.
Yes, sir.
So what do you think? Statement is correct or incorrect?
Can be used.
Can be used, right?
Yes, then
So
only statement is correct, sir.
yeah,
Will be.
but he's saying that we cannot use. So statement is incorrect,
No,
right?
that's so in case, sir.
Yeah. So second option, bentonite clay. There's multiple correct here.
Okay, sir.
You know why we use clay in landfill lining?
Yes, sir. Canal lining, we use bentonite clay. This is very cheaper one.
Yeah,
Other than constructing lined canal, unlined canal.
yeah, yeah.
The
So
very cheaper one, bentonite clay.
we
Market
we
level.
yeah, week 7. Have you attended the week 7 where sir discussed the
Yes, no,
TSDF,
sir.
TSDF facilities and the municipal landfill.
No, sir. No, sir.
So when we design those two things, no. So
Check, sir.
1 minute. So in case of MSW, municipal solid waste
Municipal solid waste. Yes,
landfill,
sir.
different layering we use is like there will be subsurface
Yes,
soil,
sir.
then there will be a layer of clay,
Yes, sir.
and then we have uh, a geotextile layer, right? We have geotextile, HDPE
Yes,
layer,
sir.
high density polyethylene,
Yes, sir.
HDPE. So HDPE is impermeable, so it won't
Yes, sir.
allow the penetration of water.
Yes, sir. Leachate
Yeah,
contaminant.
yeah, leachate. So
Yes, sir.
why we are using clay here? Like if there is any breach in HDPE, like it is a very thin, not very thin, but a comparatively thin layer, right?
Yes, sir.
Few mm's only.
Yes, sir.
But if it get teared, then we are using a lower layer of clay. So why we are using clay? Like there's something special about clay. Why we are not using sand?
The sand is more pores, sir. Clay, there is no pore. Like impermeable layer.
Yeah, it is impermeable. Permeability is very low, 10 to the power minus
Yes,
7
sir. Yes, sir.
centimeters per second, right? It's very low.
Yes, sir.
That's why. So, what do you think? In this case, this barrier for contaminant for chromium can be constructed or not? This
Yes, sir.
contamination, this
Yes,
contamination,
yes.
yeah.
Yes, sir. Constructed, sir.
So should like for this question, it is correct or not?
This question, the statement is correct statement. There is, அதனால அதுக்கு no, sir. The statement is correct. Question asking is incorrect, sir.
Okay.
That's
So
why no
here,
choosing B option, sir.
yeah, here it won't be the answer, right?
Yes, sir.
Okay. So third option is
And question is correct means option B is correct, sir.
option B is correct.
Question is which of the following statements are correct means the option B is correct, sir.
Okay. If question was different, then it would have been different.
Oh,
But in this
yes,
question,
sir.
it is not correct.
Okay, sir.
We are asking incorrect only.
Yes, sir. Yes, sir.
This
That's why
statement is
B is
correct.
incorrect, sir.
Yeah.
Hmm.
Third option, complementary technique.
Incorrect, sir.
Incorrect.
Yes, sir.
Means we cannot use.
Yes, sir.
We cannot use. So if for this option, it will be correct or not?
Correct, sir.
Okay. So basically, these two will be correct.
Low master content and waste decrease the cost of treatment, sir.
What will be the answer?
False.
Okay. This is
Sir,
numerical.
exam will be like this only, sir.
Some problems will be like this. Some problems will be numericals.
Okay, sir.
This is a numerical.
Okay, sir.
Try to solve this, and then we will discuss.
The problem solving lecture I didn't watch, sir. Only the eighth,
You attended the lecture, right?
sir.
You attended the lecture, P8 lecture, right?
Sir, I attended the 3 lecture videos, sir. The problem solving lecture is pending, sir, for eighth assignment.
No, did you attended the V8 session which Sir took on Swam portal?
Sir, Swayam portal, I attended the, sir, 4 videos, sir, available, sir.
Yeah, 5
4
videos.
part. Yes, sir. I attend only the first 3 only I will watching, sir. Now 2 only pending, sir. The assignment due to 20 means that's why pending, sir, the 2 video.
Jadhav, have you attended? Jadhav?
Is there any formula means, sir, I will solve, sir. To guide me.
What? Ani, actually, I will explain. I will explain it. No issues.
Okay, sir. Sir, is there any chance to postpone the exam, sir, due to election?
I don't think so.
Okay, sir. Okay.
These are online exams only. So
Because we are in Tamil Nadu, here April 19, exam is April 20, they say, that's why.
I don't think so. Here it will be delayed.
Okay.
Because most of the times on portal, even whatever activity is there, it won't affect the classes or exam,
Okay.
whatever holiday is
Okay, sir.
there, it won't.
Okay. Sir, any chance to watch previous live videos, sir? Recorded videos available, sir.
Yeah. It is available in. Actually, you might have got a link of one in this Google Sheet.
Yes,
This
sir.
one,
Google
this,
Form.
the
Yes, sir.
yeah.
Google Form.
No, not Google Form. Google Sheet.
Yes, sir. Yes, sir.
Uh,
Like
the
spreadsheet.
spreadsheet. Yeah.
Yes, yes, sir. Yes, sir.
So there, all the links for the videos as well as the previous presentation PPTs, all
Assignment. Yes, sir.
yeah. No,
Assignment discussion. Okay.
not assignment.
Thank you.
Wait 1 minute. Can you see this?
Yes, sir. Yes, sir. I see, sir. In Swayam portal, sir. I will see this, sir.
No. This sheet is. Have you seen this sheet where this YouTube links are there and
Sir, in Swayam portal, the last tab is problem solving.
yeah.
That's why here available, sir. This sheet
Yeah.
available, sir.
Yeah.
I
So
will touch the link means this here available, sir. This sheet available, sir.
from there only you can see these videos, all the problem solving
Okay,
session
sir.
videos, as
Okay,
well
sir.
as
Thank you
the
for guiding, sir.
presentations are also available.
Okay, sir. Okay.
Can you see the PPT now?
Yes, sir. Yes, sir.
Okay. So you have attended 3 lectures, no? So you might have seen this formula, right?
Okay, sir.
MT by M naught equal to 4 diffusivity constant time divided by pi
Sir, are you sharing the screen, sir?
length square. So you are not able to see the presentation?
Yes, sir.
Okay, 1 minute. Now you able to see?
Yes, sir. Yes, sir. Yes, sir. I can see, sir. No.
Ha
No able.
have you seen this formula?
Yes, sir. Yes, sir. Yes, sir. Mu d naught s t by pi d square whole power 1/2.
Yeah, for D observed, that is observed diffusivity
Okay, sir.
coefficient at
Okay, sir.
time, and
Okay,
pi
sir.
to L square.
Okay, sir.
So this formula actually sir derived through uh, when we are taking, like, there is a, like, this is a solid block, and there will be some, it will be, has some permeability, right? So there will be some path of
Okay,
permeability.
okay, sir.
So through that, sir derived this dc by dt. So around this there will be flow, right? So dc by dt equal to the diffusion because there won't be any advection, right? Because
Okay, okay,
the
sir.
contaminant won't, because there is no entering of water into this block.
Okay,
So
sir.
the flow is very slow. So there won't be any advection mechanism where the
Okay,
contaminant
sir.
travels with water, like in the flow, in
Okay,
direction of flow of water, contaminant also travels. So
okay,
there
sir.
won't be any advection, but diffusion happens due to concentration gradient, right?
Okay, sir.
So there will be movement of, like, if there is more contaminant inside, so that
Okay, sir.
contaminant might move outside because the concentration outside is low as compared to
Okay, sir.
concentration in the block.
Next, sir.
So for that, we can write equation where variation of concentration with respect to time will be equal to diffusivity coefficient
Yes, sir.
and concentration, double derivative of concentration gradient,
Okay, sir.
and there might be some reduction in concentration due to some degradation
Yes,
activity and all those things. So this variable
okay.
basically represents whether there is some formation of contaminant. You might have heard of mass balance, right?
Yes, sir.
Where we write accumulation of something is equal to how much something is entering into the system, how much
Yes, sir.
some compound is going out of the system, and
Yes, sir.
how much, if there is some chemical reaction happening within the system, because of that there is formation of particular compound or destruction of particular compound. So for that third term we are writing this, whether there is some
Yes, sir.
activity, because of that there is reduction in the uh, particular compound or contaminant which is present inside.
Okay,
So
sir.
so we will assume that there is no such type of reaction happening. So we will assume it to be zero. And
Yes,
now
sir.
we have this equation.
Okay.
So if you solve this equation, you will get this equation.
Okay, sir.
So basically, this equation which sir derived, we are
Yes,
going to
sir.
use this equation for deriving a formula which will be used in this problem.
Okay, sir.
So how did he do it? Let me derive that. So we know this formula, right? dq
Yes,
by
sir.
dt. dq by So, this question is basically based on solidification stabilization, right? So,
Yes, sir.
and it is done in XC2. XC2 means we have taken the soil from that particular place, then we have, like, we are not injecting the stabilization or solidification material directly into the land. We have excavated the material, right? XC2 means that only, right?
Yes, sir.
So
Yes, sir.
we are taking, so we must have formed certain blocks of, right? And we have buried it inside in underground. This is the ground level. So there's some water coming from upward direction. So if we are assuming that there is some diffusion means the high concentration contaminant present in these blocks are coming out into this water because of concentration difference or concentration
Okay.
gradient. So this
Okay.
this water will have some contaminant and we will call it leachate. So this
Yes, sir.
leachate will get added into the groundwater, right? So
Yes, sir.
it will contaminate ground.
Yes, sir.
So this diffusion mechanism, like if we are assuming this, the discharge, the flow rate, this water is penetrating into this ground. This flow rate
Yes,
is,
sir.
let's assume it to be QL, and the concentration which is coming in this water is Cl. Concentration of
Yes,
contaminant
sir.
after dispersal in this
Okay, sir.
flow is Cl, and the flow of groundwater is like QGW, Q like QG, and concentration. If there is some, if already that if we assume it to be X contaminant, there might be some possibility that that X contaminant is already present in groundwater, right? So we are assuming that concentration to be Cg. In most of the cases, we can assume it to be zero, but there might be a case where this contaminant is already present in groundwater, right? So once these two streams, QLCL and QGCG, get mixed, so we will get a resultant where we are assuming discharge to be QR and concentration to be CR, right? So what do you think? What will be the relation between CL and CR? Which one will be larger?
CR means, sir?
CR. Concentration CR will
Yes,
be
sir.
larger.
Sir, no, sir. What is my CR, sir?
No, concentration, there is some contaminant X which is present in these blocks and it is coming out into water. So the concentration is Cl in that water. And then that water is mixing into groundwater. And then resultant concentration is Cr, because there might be some concentration of this X contaminant in groundwater already, right?
Yes, sir.
So which one will be higher? Cl will be higher, Cr will be higher. Let's assume that Cg value is 0.
Leachate, concentration of leachate is higher, sir.
Why?
The leachate is the initial concentration, sir. After that, some soils are absorbing the contaminant and it penetrates through the ground, sir.
No, it is coming out of the soil only. That this block
Yes,
is
sir.
solidified. No, from this it is coming out to the water. It is
Okay,
higher
sir.
because CR value is lower because this is large volume, right?
Yes,
Concentration.
sir.
What is concentration? Mass by volume.
Okay, sir. Okay, sir.
Milligrams per liter. Mass by volume.
Yes.
So here
Okay,
volume
sir.
is less. Volume is less. Now,
Yes,
when
sir.
this Cl gets added into this water, there is
Yes,
increase
sir.
in volume,
Yes, sir.
right? But mass is same.
Yes, sir.
When we are assuming that Cg is 0,
Yes, sir.
right? So obviously the C value will come down because
Yes, sir.
denominator is higher value now.
Yes, sir. Yes, sir. Yes, sir.
So yeah, that's why. So uh, after this, so we can write that QL into Cl plus,
Like continuity case, sir.
yeah, Qg into Cg, like continuity equation, yeah,
Yes, sir.
equal to Qr into Cr. So if you multiply Q in C, what unit we get? Basically, we get like milligrams per unit time.
Gram per day.
Yeah, mass flow rate.
Yes, sir.
So mass balance equation. Yeah,
Yes, sir.
okay. So this is one equation. From here
Yes,
we can easily find the now what is this QR value?
sir.
This QR value will be addition of QL
Plus QG.
uh, QG. So we can easily find the CR value if we know this information, right?
Yes, sir.
So we can write CR equal to QL CL plus QG CG divided by
Divided by QR.
QL plus QG. Now, but this is applicable in case of when we have uh, equivalent condition
Yes,
where
sir.
equilibrium control is there. For example,
Yes, sir.
this dispersion, no, this diffusion which is happening from this solid block into the water. There
Yes,
will be
sir.
some rate of diffusion, right? So
Yes, sir.
if then if this flow rate, this water flow
Yes,
rate, which is come
yes,
in
sir.
contact with this block, if it is this flow
Yes,
rate is very high, then
yes, sir.
it won't have sufficient time for dispersion to happen, right?
Okay, sir.
So if it won't give the sufficient time, then we won't reach the equilibrium condition,
Okay, sir.
right? So in case of equilibrium condition, this what we did is correct, right? We
Yes,
can
sir.
find the value directly here. This
Okay,
CL
sir.
value will be equilibrium condition only. Now,
Okay, sir.
this will be the highest. This will be highest value which this condition could achieve. But if the
Okay, sir.
flow rate is high, this CL
Yes, sir.
value won't be CL. It will be something like CL dash,
Okay, sir.
which will be lower than CL value
Okay,
because
sir.
flow rate is very high. That's why
Yes.
it won't have sufficient time for the dispersion of contaminant into the water,
Okay, sir.
right? So
Yes,
in
sir.
that condition is called as kinetic control.
Okay, sir.
So in case of kinetic control, now we have to consider the dispersion equation which we derived here, this
Okay,
value,
sir.
to
Hmm.
calculate the CL value.
Okay.
So how we will do it is, so the QLCL, no, QLCL, this CL value we can't take it as highest value because equilibrium control is not there. So this CL value we have to find out. So this value will be equal to basically CL value which we have to use this formula. Yeah, this dc by dt we were using, no? This C we can write as dm by dt, right? The variation of mass with respect to time. QL QL into dm by dt. So here basically this whole thing can be written as m naught derivative of uh, this m value, no, mt.
Yes, sir.
Mt we know from here. Mt is equal to m naught and this whole thing.
Yes, sir.
So dm by dt m naught for d. So when we integrate it, there will be t to the power 0.5. When you integrate it, there will be this whole thing QLCL. You understood now why we wrote it dm by dt? This whole
Yes,
thing
sir.
QLCL,
Yes, sir.
right? So this whole thing, when we differentiate it, it will be what value we will get is m naught you understood it, right? Point five, 0.5 minus 1, then it will minus 0.5 and t will come in the below.
Okay,
Okay.
sir.
So this will be the formula QLCL.
Okay.
So we can further modify this formula, but like for if we want to calculate CL, it will be m naught divided by QL. And here L square is there and 0.5 is there. So we can take out L outside, right? It will be D divided by pi T 0.5. Now you have to use this formula
Sir, where is two here, sir?
to which two?
Number two is missing, sir.
To what?
Sir, the differential of t power 0.5
Uh-huh.
is 1 by 2 divided by t power 1
No,
by
this
2.
this 4 is also there, no?
Yes, sir.
When
4 by 2.
4, no, not 4 by 2. That 1 by 2 will be outside.
Okay, sir.
It won't be inside, no? So when you bring this 4 outside, it will become 2 because under root
Okay,
is
sir.
there.
4 power 1 by 2. Okay, sir. Okay, sir.
Yeah.
Okay, that's okay. Understood. Now understood.
So you have to use this equation now to solve this numerical. So you just
Okay.
write this equation and then try to solve this question.
Okay, sir.
Write this equation in your notebook and try to solve.
Okay, sir. Note, sir. Sir, any unit is converted or whatever.
What?
Sir, any unit is converted or whatever of it is, sir, we will do.
Unit conversion.
Yes, sir.
Units you have to convert. Like as per requirement, like in formula, you're going to put all these values, right? So
Okay.
you must bring all these values into similar units so that you can cancel out, right?
Okay, sir.
And at the end, you want value in milligrams per liter.
Okay, sir. Please solve, sir. No idea.
क्या नहीं हो रहा है क्या?
Yes, sir. It's difficult to convert the unit, sir. That's the power of points.
अच्छा, आसान आसान यार. I'm not his mass, right?
Yes, sir.
So calculating mass, the information which we are given is a volume we are given.
Yes,
Uh, volume of the total area which
yes,
we need to treat, and the
yes, sir.
concentration of arsenic in treat material is this grams per
Also,
meter cube. Concentration
yes,
is
sir.
given.
Yes, sir.
So concentration is mass by volume.
Yes, sir.
We have volume into volume, so you will get mass,
Yes,
right?
sir. Yes, sir.
So m naught you can calculate directly. So concentration into volume. So m naught. So the m naught value is sorted. We can calculate it with C naught and V.
Yes, sir.
Then other information is time after disposal of treated materials.
Yes, sir.
So
90 days.
90 days. So
Yes, sir.
it is given, T is already given. So based on, like, if let's convert all the things into uh second, like time into
Yes, sir.
seconds and matters, basically matters. So this mass value will be in grams.
Yes,
So
sir.
we can keep it in grams, no issues, because we have to convert it into milligrams. So gram will be fine. 90 days per day, so we can convert into, either we can keep it in days or we can convert it into seconds.
Yes, sir.
And then length of direction of diffusion, this L value is given. This L value which is required here in
Okay,
the
sir.
formula. And then we have observed diffusivity of arsenic. So this is already in meter square per second.
Yes,
This is
sir.
deobserved.
Yes, sir.
Then leachate flow contacting treated material QL. QL value is also given. So this is basically the flow rate, this value, this
Okay, sir.
value.
Okay, sir.
And groundwater flow approaching. So this is the groundwater flow rate QG for in our example this value QG value.
Okay. Okay, sir.
And then we have assumption only diffusion is occurring. So that is
Yes.
okay, no issues. We have derived formula according to that only diffusion.
Okay, sir.
So he is asking to calculate CL value, the concentration,
Yes, sir.
equilibrium condition,
Yes, sir.
arsenic and leachate.
Okay.
So this CL value we have to calculate.
Good.
Sorry, this CL value, which in equilibrium condition after diffusion, some value concentration of contaminant in the water.
Okay.
So we can use this formula directly. The CL equal to m naught
M naught. Whatever.
m naught by QL into L. This QL value is there. L value we have this. M naught value we have to calculate. Uh, into the observe the observe value is there, which it will come here, and then pi t. So time is also given. So we just have to put values. So for putting values, let's assume if we are calculating m naught 90 days, m naught is this 1150. QL value is given in meter cube per year.
Yes, sir.
This we have to convert 11 meter cube per year. So if you convert year into, we have to convert everything into seconds. So you can just multiply it by 365 into 24 into 3600. So this will be converted into year,
Yes, sir.
right? This will be converted into seconds.
Yes, sir.
This is seconds.
The answer is 13.35, sir.
Yeah. 13.35.
This is correct, sir.
Yeah, 13.35 is correct.
Unit
13.35
milligram per liter, sir.
milligrams per liter. Yeah, in milligrams per liter, that will be the value.
Okay, sir.
So D observe is given that 2.1 into 10 to the power minus 14 meters square per second. 3.14 into time is 90 days. So days, if you convert this into seconds, you have to multiply it with 24 and 3600. right? So and power 0.5. If you solve this whole thing,
Yes, sir.
you will get CL value to be somewhere around 13.35 something.
34894,
Yeah,
approximately
milligrams
13.
milligrams per liter. Yeah. Initially, you will get the value in grams per meter cube,
Yes, sir.
but when we convert it, no, so in both sides there will be 10 ki power 3 and 10 ki power 3.
Yes,
It
sir.
will get
It will
cancelled out.
cancel.
Yeah, and it
Yes,
will
sir.
become milligrams per liter. So this is the answer. Okay. Jadhav left. This is the next question, next problem. Next question. This is the extension of the previous problem.
Yes, sir.
So here he is asking basically the problem, the derivation we discussed, no, this
Yes, sir.
mass balance. So he is
Yes,
basically
sir.
asking the value of CR.
Yes, sir.
Like after we mix both these things, what will be the value of the combined concent after combining these wastewater and the groundwater? What will be the concentration CR value? So you just have to put the mass balance equation.
Yes, sir. So what is concentration of CGW? How much, sir?
EGW,
How much, sir?
uh, PGW, QGW, no?
Yes, sir.
So it is 1130. Discharge rate is 1130, and concentration you can assume it to be zero because it is not given in the question.
So concentration is 0, sir.
Yeah, we can
Okay,
assume
okay.
the concentration value to be zero because it is not given.
Okay, sir. Okay, sir. Okay. Mm. Sir, 1835.62 meter cube per year.
Right?
18 0.35.
0.18, yeah, correct.
That's the right or wrong, sir? 18625
Yeah, correct answer.
meter cube per year unit, sir.
Yeah, 0.18 is correct. Meter cube per year, I think it will be in meter cube per year. Let's calculate. ULCL.
Hmm.
The CG value is already given here. Hey, uh, Karuniraj,
Yes, sir.
the value is also already given, no? See the CG value.
Okay, sir. Okay, sir. Okay.
It won't be 0. What is the value you are getting?
So quantity of arsenic, sir.
0.204.
Sir, quantity of arsenic is given in question, sir.
Yeah, the answer for the question you're asking for answer for the question.
No, sir. I'm asking data.
Data CG
Quantity
value.
of.
See in the groundwater, no groundwater.
Yes, sir. CG value. Okay, sir.
CG value is 0.08. 0.08.
Okay,
It is
sir.
given
I am asking QR. QR. Q suffix R means concentration of, sorry, quantity of arsenic.
QR.
Yes, sir.
QR is not quantity. QR is flow rate discharge.
So how much, sir?
QR will be addition of QL and QG, no?
Okay, sir. Okay, sir. Okay, sir. Okay. 21.77.
21.77.
Yes, sir.
No, 0.205 something. 0.205.
0.20.
5 milligrams per liter. I, are you able to see the slides?
Yes, sir. I am able to say, sir. Sir, 1 minute you see the previous slide, sir. I didn't write the full question, sir. That's why. The question slide, previous question number 6.
Okay.
1. Okay, sir. Okay, sir. I am dissing the wrong data, sir. That's why, sir.
Okay.
Okay, sir. Okay, sir. Yes, sir. 0.207.
0.20, yeah.
Yes, sir.
Okay. This is the last question.
Okay, sir.
I don't know why this.
It's take 2 timers, sir.
Why this slide is replicating.
Boring for our research, sir. Sir. Okay, sir. Okay, sir.
This is the last problem.
Okay, sir. Yeah, this is like EH diagram, sir.
Yeah, the diagram which we discussed, no? pH value and solubility for different
Okay, sir.
heavy metals. So
Okay, sir.
with increase in pH, there is a decrease in solubility, and then after a particular point, particular pH value, there is again increase in
Okay,
solubility.
sir.
So what is the reason for this? These are three options you have to.
In general, solubility. Sir, metal complex.
But,
Yes, sir. That's the right or wrong?
so can you explain like why you said metal complexes?
Sir, saying video, I will remember, sir. Now only I remember.
Metal complexes. Do you know
Yes,
the
sir.
reason why like what is the here difference between metal hydroxide and complex?
Metal hydroxide means alkaline group. OH concentration.
And in complex?
Complex means further other than hydroxide,
No,
like
not other
sulfate.
than no, acha, like take an example. Here Pb
Hmm.
OH
Yes, sir.
thrice. This is hydroxide only.
Yes, sir.
Is it a complex?
Yes, sir. Two. No idea, sir. Please explain. Sir,
Yeah.
please explain,
So
sir. No idea.
this is a hydroxide, right?
Yes, sir.
But this normally, if you increase, like for if we take an example of lead, here
Yes, sir.
if we are increasing the pH, like for example, you are increasing the OH minus ion
Yes,
concentration
yes, sir.
continuously. So what happens is after a particular pH, normally the compound which will come out of the system from the water, or the solubility will reduce or will get precipitated is uh,
Okay, sir.
OH2.
Yes, sir.
But if you continue increasing the pH value, the lead
Okay,
will
sir.
start making compound with additional OH present
Hydroxide.
in. Yeah.
Yes, sir.
So this OH3 minus is also hydroxide, but it is a complex. Now
Yes,
Pb
sir.
is surrounded by uh, three OH ions.
Okay, sir.
So so in similar way,
Yes, sir.
that's why so these complexes are soluble actually.
Yes, sir.
So that's why there is again increase in solubility.
Okay, sir.
So, yeah, that's right. So, second option is correct, but this is the like sort of reasoning.
Okay, okay. Now only I can remember.
Okay, okay. Today I only have this many questions. You can,
Okay, sir.
yeah, you can like leave.
Okay, sir.
Yeah,
The previous sessions also like that, sir.
what?
I am only sir, attending, sir. That's why I'm asking.
Actually, not like many students are not attending. Hardly two or three students will come.
Okay, sir.
Most of the students are not attending.
Okay. About you, sir?
Oh yeah, you can log out. Yeah, you can go. No issues.
No, sir. About you.
About me.
Yes, sir.
Actually, I'm doing my PhD in IIT Delhi.
Okay, sir. Okay, super, sir. Super.
Yeah. So
Okay, sir. Okay.
there's one scheme called PMRF.
Yes, sir. Yes,
I'm
sir. 75,000 scholarship for new initiative idea
yeah,
for continuous 3 years. Yes, sir. Okay, sir. Okay, sir.
yeah. So for that under that fellowship, we have to do some TA work. So
Yes, sir.
this classes comes under my
Oh,
TA.
okay, okay. Okay, sir. Okay, sir. Okay, sir.
Yeah.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Okay.
Thank
Bye.
you. Okay,
Bye.
sir. Bye.
Good night.